Hello, in this video, we will use the Google LINEST function in performing the logistic relax regression analysis. Here we have a dataset where the outputs are in the 1 and 0 values, while the input are in the linear values. So we show the equation of this using the chart, the Google, the chart, the scatter plot chart. And we show the equation, the linear trend line equation as label, and also we should show the r square value. So here we have a trend line equation, which is y equals 0.25 times x plus, or this is net minus 0.184. We can use the LINEST function of data y and data x and show the full statistics. So here the coefficients B1 is 0.2499, which is 0.255x, and coefficient B0 is negative 0.184, or negative 1.1839, which is rounded up as negative 0.184. And our r squared is 0.4155, which is rounded up as 0.4166. We'll use the matrix operation and some functions to calculate for each of these output, starting with the slope. The slope can be calculated by its own function, which is 0.2499. B1 matches to our LINEST output. The intercept is, we use the intercept function y and x, which also matches negative 0.1839, matches to our LINEST output. We can also use the r squared, which is rs cubed of y and x, and this match to rs cubed, the LINEST output, and the stay x, which is stay x, y values, and the x values also matches to our LINEST output of stay x. Next, we calculate for the degrees of freedom, which is equal to rows minus column. So the number of rows, start with this one, rows of the dataset range. So our population is 18, and DFD is rows minus column equals rows minus columns of the dataset range. So our degree of freedom of the denominator is 16. Next, we calculate for the residual sum of square, which is DFD times stay x to the power 2. And this matches to our LINEST output. Next, we calculate for the regression sum of square, ESS equals n times variance of population y, which is this, minus RSS. 1.847 matches to our LINEST output. The F statistic equals the ESS divided by degree of freedom of the numerator, which is 1, because we only have one independent variable or one x uh, predictor, all over RSS divided by degree of freedom of the denominator. So 11.377 matches to our F statistics. Next, we calculate for the standard error values of B0 and B1. To do that, we complete the Pijarina inverse matrix, starting with the 1x matrix. So this is equal to minverse M mult transpose of this matrix with the 1x matrix and itself. Now we can calculate for the standard error of B0, which is equal to stay x times square root of Pijarina red. And this matches to our LINEST output. Standard error value of the B1, which is equal to stay x times square root of Pijarina blue. And this matches to our LINEST output. This completes the logistic relapse regression analysis using the Google LINEST function.